Hi, this is Group I, and our topic is how does age affect the importance of insurance? My name is Liang.
Brittany Palmer.
Nicola Fletcher.
and Marie Chua.
For our research topic, we chose on how does age affect the importance of insurance. We looked at the population from ages 18 to 50 and higher. The purpose of our topic is to understand the knowledge and the values of insurance from different ages. In our hypothesis, we hypothesized the adults and the older would value having insurance more because health becomes more of a priority. From our data collection, we collect our data by having each member collect surveys from people in our surroundings or through social media. We used Google Forms to survey our participants. This can be done in person by using a tablet, phone, or laptop. We have collected 81 surveys in total. The issues we faced when we collected our data is only 6 people out of the 81 participants states they didn't have insurance. So we had to exclude some of our survey questions when we used our data to answer the research question. For instance, how long have you been uninsured? For our first individual hypothesis testing, my research question was, what is the relationship between age and their knowledge of their insurance policy? The reason for this question is by analyzing the importance of by analyzing their level of understanding for their insurance, we can deduce the importance of health insurance in their mind. For our hypothesis, the null hypothesis is there is no relationship between participants' age and their level of insurance knowledge. For the alternative hypothesis, there is a relationship between participants' age and their level of insurance knowledge. For our statistical test, I chose Pearson's correlation test because it analyzes the relationship between the two interval level data variable. And for our statistical test, I had to look at the assumptions and the critical value. For our critical value, we say that results will be significant at alpha equals 0.05. And our first assumption that we have to meet for our Pearson's correlation test is both variables must be continuous. And our second assumption is both variables must be normally distributed. To meet our first assumption, the value has to be interval ordinal level data, and this assumption is supported because both of my variables are interval level data, so they are continuous. For our second assumption, we need to meet this by having a skewness and kurtosis between -1 and 1. We also need the bars on the histogram to align with the normal curve. So for this test, I created a kurtosis and skewness table. And as we can see, the values from the red box, it is between -1 and 1. So this assumption is verified. And also with the histogram, we can see the bars are aligning with the normal curve. So we can assume that both variables must be normally distributed. So I created a Pearson's correlation test and reported my findings. It states that it is significant positive relationship between the age and their level of knowledge on their healthcare insurance. The variables also have a low relationship. I determined this by looking at the sig2-tailed, which tells me that is significant relationship because P is less than 0.05. I know that it was a positive relationship because the Pearson's correlation value is a positive number. And it showed it was a low relationship because the Pearson's correlation number was between the range of 0.1 to 0.3. I also created a scatter plot, and this scatter plot tells me there was a low relationship between the variables as supported by the Pearson's correlation test. And I know this because the data points are scattered everywhere. There was also a positive relationship because the data points are moving up from left to right. So to interpret my findings, the significant relationship at p less than 0.05 tells me that I can reject my null hypothesis and state there is a relationship between age and their level of knowledge on their health insurance. The low and positive relationship found from my scatter plot and Pearson's correlation test tells me that as age increases, so will their knowledge on insurance, but only by a little. The coefficient of determination that I found squaring, by square rooting, by squaring my correlations coefficient and times it by 100 tells me that only 8.4% of variability in people's level of knowledge in health insurance can be explained by their age. Next would be individual hypothesis testing for number 2.
So the research question would be, is there a relationship between age and the length of time it takes to understand their insurance? The reason for this question is to know how the participants value their health insurance by the length of time it took them to understand their insurance policy. The hypothesis, the null hypothesis, is there is no relationship between age and the length of time in understanding their insurance policy. The alternative hypothesis is there is a relationship between age and the length of time in understanding their insurance policy. So the critical value, that the results will be considered significant at alpha 0.05. Statistical testing and assumptions. In order to test for a relationship between age and the length of time in understanding their insurance policy, I ran the Kendall's tau and Spearman's rho correlation test. The assumption is that one variable is categorical. The second parametric assumption is that the data is measured at the interval or ratio level, which are data violated because the measurement is at the ordinal level. The Pearson correlation cannot be run. Instead, the Spearman-Rose correlation and Kendall-Stau's correlation test. So this shows the age is measured by ratio, and then the length of time it took them to understand is by ordinal level. So for the testing, the report shows that according to Kendall-Tau's, there is a significant positive relationship between age and the length of time in understanding insurance policy, which is in red font, that is 0.24, and the significant level is equals to 0.007, which is the correlation becomes significant at the 0.01 level. There is a low relationship since the correlation efficient is between 0.0, 0.1, and 0.03. So as showing the interpretation, it shows there that there is a low relationship. And then according to the Spearman-Rose, there is a significant positive relationship between age and the length of time in understanding insurance policy, as shown in the red font, of 0.32, and a significant test is at 0.006. There is a medium relationship since the correlation efficient is between 0.3 and 0.5. So interpretation findings is given that both Kendall-Tau's and Spearman-Rose reported a positive significant correlation coefficients and significant levels when testing the age and the length of time in understanding of insurance policy. It shows that there is a relationship between these variables. Therefore, I can reject the null hypothesis and must assume that there is a positive significant relationship It indicates that as age increases, the longer it takes them to understand their insurance policy. This means that I have enough sufficient evidence to claim that there is a connection between age and the length of time in understanding of insurance policy. The next one will be Nicola will presenting the hypothesis testing number 3.
Research question is, what is the relationship between ages in years and years insured? The reason for this question is our participant value their insurance with regards to the length of time being insured. The null hypothesis state that there is no relationship between the age in years and the length of time being insured. The alternative hypothesis state that there is a relationship between the age in years and the length of time being insured. All right, assumption 1, both variables are interval and or ratio. The age in years and the length of time being insured are both numeric and continuous. Therefore, this assumption is not violated. Assumption 2, the data for both variables are normally distributed. This assumption is violated. As you can see, I did a statistic. I run a skewness and kurtosis test. And as you can see, for what is your age, both skewness and kurtosis are within the normal range of -1 and +1. However, for question 5, how long have you been insured in age? The skewness falls slightly out of range, which is 1.069, and it should be in the normal range of -1 and +1. Because of this, I have to run a Spearman and Kendall correlation test instead of the Pearson correlation test. Here you can see the histogram confirms also that number 5, how long you have been insured in years, has been violated, out of range. This is a correlation test run. And as you can see, the p-value and the r-value, and the r-value, they are above the critical value, which is 0.05. For the Kendall, it states that the r-value is 0.09, p-value equals 0.320. The Spearman, the r-value is 0.10, and the p-value is 4.21. Both these values indicate that there is no significant relationship between age in years and years insured. Given that both Kendall and Spearman correlation indicate that there's no significant correlation between the age in years and how long you have been insured, it indicates no relationship between both variables. As a result, I was unable to disprove the null hypothesis and must therefore conclude that there is no meaningful association. I lock support for my assumption that there is a relationship between age in years and the number of years insured. Here I also run a scatter plot, and this also shows that there is no significant or low significant relationship between both variables. As the dots on the scatter plot has no formation, they're scattered. And if there was a relationship, it would show a linear line going from left to right, upwards. As you can see, diagram 1 shows an example of when there is a positive correlation. You can see it's a straight line. Diagram 2 shows a medium correlation. Line 3, a small negative correlation because the line is going from right to left instead of left to right. Number 4 also concludes from my my scatter plot run that there is weak or no correlation because the dots are scattered.
Hi, I'm doing mine on is there a relationship between age and their insurance satisfaction? The reason I chose this question is to see the difference between the satisfaction rate between with age and insurance. Hypothesis is there my null is there is no correlation between age and insurance satisfaction, and my alternate is there is a relationship between age and insurance satisfaction. All right, my critical value result will be considered significant at alpha equaling zero point zero 0.05. In order to test the relationship between the two variables, I will run a Pearson correlation test. Um, Assumption one is both variables must be continuous. This was violated because the insurance satisfaction was an ordinal level data and is not continuous. Assumption two was both variables must be normally distributed. This was also violated because ordinal level data cannot be normally distributed. Because these assumptions of continuous variables and normal distribution have been violated, I will run a Spearman and Candle tool instead. Okay, in order to test my hypothesis, I will run the Spearman and Candle tool. My correlation coefficient for my candle is low because it falls between zero point 0.1 and zero point 0.3, as you can see in the arrow. And then my correlation coefficient for Spearman was medium because it was, when I round up 0.26, it gives me 0.3. The significant relationship is less than zero point 0.5, which is positive because my numbers are positive. All right. According to Kendall-Toe, there is a positive significant relationship between age and insurance, R equal 0.21 and P equal 0.021. This is a low relationship because the correlation coefficient is less than zero point 0.3 as shown in the diagram. According to Spearman, there is a positive relationship between age and insurance satisfaction. My R equal 0.25, my P equal 0.020. This is a median zero my p value sorry 0.0 p value equal 0.020. This is a medium relationship since the correlation coefficients can be run up to 0.3. Given that both Kendall and Spearman were reported low and medium correlation coefficient and greater significant levels when testing whether or not there is a relationship between insurance satisfaction and age group. As a result, the data do support the relationship between the two variables. I reject the null hypothesis and must assume that there is a significant relationship. This means that I have sufficient evidence to claim that there is a connection between age and insurance satisfaction. I accept my alternative hypothesis. The coefficient of determination according to Kendall-Toe 0.212 times 2 equal 4.64 equals 0.460. This means there is a 46% of variability in the relationship between age and insurance satisfaction. And according to Spearman, 0.268 times 2 equal 0.517. This means that there is a 51% variability. Okay. In conclusion, looking at our results from the 4 correlation tests, one out of our 4 tests shows no correlation. Age and the years insured had no significant relationship, implying that their insurance status is not impacted by age. Additionally, only 6 participants stated they do not have insurance. As a result, we did not have enough information to conclude age is a factor in influencing their insurance status. Rather, there might have been other variables influencing their insurance status that we did not explore. However, based on the 75 participants who stated that they had insurance, there was a significant positive relationship between age and their insurance satisfaction. So the older the participant we see, the higher satisfaction with their insurance. This can be partially explained by the number of years they had to understand their insurance, as there was a significant positive relationship between age and the years it to took them to understand their insurance. Additionally, there was a significant positive relationship between age and their level of understanding of their insurance, implying that as age increased, we also see an increase in their level of understanding of their insurance. However, only 8.4% of the variability in people's level of knowledge of health insurance can be explained by their age, which indicate age had only which indicate age had only a little impact on people understanding insurance. In conclusion, we do not have enough information to prove our hypothesis that adults and the older population will value having more will adults and the older population will value having insurance more. However, we can conclude that there is a relationship between age and how well they understand their insurance. As we create a holistic care plan for our older population, we have gathered information that will help us gauge our patient understanding of their insurance, and as a result, we are able to implement different teaching methods to further their knowledge. Based on their insurance satisfaction, we can continue to emphasize the benefit they already have on their current benefit, which will all allow the patient to be more compliant with following their plan of care. And that concludes our presentation. Thank you.